3D printers. 3D objects are almost everywhere. Even while sitting at my room, I can locate a 3D object inside my maths textbook, a random box like at the corner, a cloth cabinet, the Rubik's stone on my desk, a hardware accessory fitted on my steel chair, as a print on my curtain, and the list goes on. I think I need to limit my view. So what exactly is 3D? Comparing it with the known 2D, 3D objects are characterized by the ones that have depth or height in addition to length and width. We identify a third dimension when we look at the object at a high angle where a third point is placed above or below horizon, creating a sensation of height or depth. What is 3D printer? Well, I very much know about my 2D printer sitting on my desk, receiving a printing command for my desired text to be printed on an A4 sheet. For understanding a 3D printer, first let's take a 3D object. As an example, I'll be taking this linear ball bearing for rapid prototyping. The reason for taking this ball bearing is its dimensional simplicity and view. We'll first measure size of each face or plane making up this object. What we want to do is create a virtual model for this object. First, we'll fix the value of y as we'll give some dimension to the value of y that represents our width. We'll fix it to 5 cm. As we move along the x-axis, height also increases along the z direction, taking a jump at x equal to 5 and x equal to 10 cm, very well noted from the diagram. In addition to this, there is also a hollow circular cavity in the middle that needs to be incorporated in the design. With this size and dimension summary, we have created a table. We'll give this table to a 3D printer software. Apart from this, density and type of material to be used for prototyping the object is also given. The last step requires us to understand what kind of structure is our 3D printer. Imagine you are holding a pen to draw. You receive instructions from your brain that control your hand movement. If you want to draw a circle, a square, a cone, a sphere or anything, your brain tells you to move along a certain symmetry and taking necessary turns and rotations to complete the picture, right? Similarly, 3 motors attached to a 3D printer corresponding to each x, y and z axis control the movement for deposition of material and filling of the space to create a desired object. Once the object is created for prototyping, its functionality is checked by attaching it to the desired apparatus. Now suppose we checked and found out that we need more height. Changes can be immediately made in the dimensional table and a new object with the required modification can be checked immediately, saving hours of work. So if n parts are to be tested, can you imagine the jump in productivity? That's the potential of these 3D printers. Fast, efficient and error-free testing. Let me know what would you like to create on these 3D printers. Thank you for watching.